Welcome to AUA Focus Series, a podcast channeled by AUA Media Lab. My name is Vahe Momjyan, and today I'll be talking with Rev Lebaredian, Vice President of Omniverse and Simulation Technology at NVIDIA. Welcome. Let me introduce yourself. So you stand as a pivotal figure at an intersection of computer graphics, simulation, artificial intelligence, with over 3 decades of experience, and your career trajectory has mirrored and often driven the evolution of how digital worlds are created and how they interacted with the physical realm. May I ask you to introduce yourself? So things that we cannot find with deep research or on media.
Yeah, that's a lot of words to describe what I did. I'm not sure if most people would be able to interpret that into something meaningful. I've spent pretty much my whole career and actually most of my life working on this idea of taking the actual physical world and representing it inside a computer so we can simulate that. Primarily when I started doing this, the purpose of that simulation was to create beautiful images, for movies and visual effects and computer graphics for animated movies. But since I joined NVIDIA, I started applying those technologies to make them interactive in real time. First, so we could make video games that also produce beautiful images from these virtual worlds. But for the last 10 years or so, I pivoted from making these simulations primarily for entertainment purposes to making it primarily to create artificial intelligence, and a specific kind of artificial intelligence, AIs that can understand and operate within our physical world. Essentially robotics.
Thank you. Could you help us to define what physical AI is?
That's a very good question. I think a lot of people are pretty confused right now about what AI is in general, let alone all the different types of AI. From our perspective at NVIDIA, we've been on this journey since the big bang of AI started. It started in 2012 with the introduction of deep learning, which was done on our GPUs, on our processors, actually on a gaming PC at the University of Toronto. The first AI, deep learning type system, was called AlexNet. And what it solved was this problem of image classification. And that's a subset of computer vision, having computers understand things by seeing them. That's been a longstanding problem in computer science for many years, and it was amazing that we could even do that, any of those things. So that ushered in the first era of AI, modern AI, which we call perception AI. They're all very specific AIs that can do specific things about interpreting the world. Maybe they can understand images, what's inside them. You could use it to build self-driving cars that could see the world around them, understand speech, etc. That led to the next era, which we've now been calling generative AI. So these very specific AIs that were mostly about kind of interpreting and doing very specific tasks with specific kinds of information now became more general, and we can generate new things. That started with the invention of a technology called the transformer in 2018. OpenAI started working on the different GPTs. We had GPT-3 in 2019, 2020, I think. But the general normal people didn't get to really experience this until ChatGPT was introduced in 2022. So we've been in this kind of generative AI moment for a little while. The era we're entering, the world is now starting to call it agentic AI. This is where we're taking these very powerful kind of general purpose AIs and giving them the ability to act somewhat on their own as agents. They have agency. So they can essentially do three things. They perceive their context in the world. They make some reasoning or planning around what they see, and then they can go act. So the kinds of agents we're talking about right now are ones that live in computers. They live on the internet. They can do things for you, like maybe buy plane tickets or help you plan a trip, or maybe help you if you have customer service or some sort of thing like that. The next era is coming. Now I'm fine. This is my long-winded way of answering your question. Physical AI is the next one, and it's right around the corner. It's essentially where we take these agents that act in the realm of knowledge, in the realm of ones and zeros, and we bring them out into the physical world. We give them bodies, essentially robotic bodies, so that they can not only perceive and reason about things that are already digital in the internet, but they can do that about things in the physical world and act out here.
Thank you. So you've discussed humanoid robots as a solution to labor shortages. So this is a type of physical AI that you were just talking about.
Absolutely.
So, and you said that the only hope we have of producing the services we need to sustain our society, they will make also jobs that no one wants to do anymore, right? So how do you anticipate the transformation of labor cost? The possibilities are limitless for humanoid robots. But how do you see this transformation? So humanoid robots will basically replace everything that can be operated by humans, or there will be more like specialized machines that will do the work?
Well, today we already do have a lot of automation that's these specialized kinds of machines. If you go into any really advanced factories, usually they're either automotive factories or factories producing very advanced, high-value products like electronics, like the kinds of computers NVIDIA builds, you'll see there are many robots that are very specific and specialized to do one thing over and over again. So those already exist, and I believe those will always exist, and we'll have many more of them. But what's interesting about the moment we're in now, even though we've had the technology to build these physical robots for quite a while, we've had them for decades, you don't see that many of them in most contexts, even in places where you would expect to see them, like in a factory or in our supply chains and warehouses and whatnot. The reason for that is that in order to program these robots, to have them do something useful, it takes an immense amount of effort. It takes expertise. You need computer scientists and roboticists who really understand how they work to program them to do one thing. And it takes a long time to do that. And then once you program them, they can only do that one thing and only that one thing over and over again. So there's not many cases where it makes sense to put that much investment in building a specific line like that. The only time it makes sense is when you're producing the same thing for a long time in exactly the same way at high volumes. And so you see it in automotive factories, for example. When you build an automotive factory, you're going to have the same cars for years. You build them in high volumes and they're high value. Otherwise, almost all manufacturing, almost all things in industry are still done by hand by humans because humans are flexible. Well, now with all of the AI advancements we're making, because we have the ability to create an intelligence that allows us to instruct a computer to do things more naturally, the same way we teach each other how to do things, we have the opportunity to create an advanced robot brain. And that unlocks the possibility of us introducing more robots into industry, into all of these places we'd like to bring them, but before, up till now, has been too expensive. Well, then the question becomes, if I can build a general purpose robot brain, what is the right type of robot body I should give for this general purpose robot today? Well, if you just step back and look at all of the places where we need robots today, all these spaces were built for humans.
Yes.
For humans to go navigate. There are stairs and ramps. There are things placed on shelves at different heights. We assume that they have, whoever's going to operate in the space has legs and 2 arms and eyes that are facing in this direction. So since all of these spaces already are built for humans, the most natural general purpose robot body we'd create would be something that looks like a human, and that's a humanoid. For now, that makes sense. I think this is really important that we advance this quickly, because this will be the best way for us to bring this kind of automation with general purpose intelligence into all the spaces and have them be useful. It also makes it so we can finally have a true robotics industry, because up till now, robotics has actually been pretty small. There aren't that many robots in the world, and they're all kind of different and bespoke. We need a robotics industry that's a full ecosystem, so that we can invest deeply in that from many, many different sources and markets and economies to really advance it quickly. And so investing in one thing is good. But over time, I think what we're going to see is once we introduce more and more of these robots into these factories, we'll start optimizing them even further. And then we'll make more specialist robots. Maybe it'll make sense for the robot to have 3 arms and 7 eyes. And instead of legs, it can have wheels in some cases. That's okay. We'll start modifying them.
Thank you. So you articulated that to teach these robots, we need data. Mm-hmm. And the data is renewable engine, right? So essentially for physical AI, this is the best input we can give, because the data is scarce in reality. So we need to gather all that visual data and then reproduce and then train the robots on this. So how do you approach verifying those simulations, like all this synthetic data, to teach robots to behave correctly in the physical world?
Very, very good question. Yeah, the fundamental problem we have is, we have this ability now to create artificial intelligence. We do that in a very, very interesting new mechanism for writing software. This was the fundamental thing that changed 10, 12 years ago when this AI was introduced. Up until that moment in time, the only way to write, to create a new kind of algorithm, to create a new kind of software that advances the state of the art in computer science, was to have a really intelligent human kind of figure out what the rules are and transform those rules into code directly. And we'd write it. And for many problems, we just don't know how to do that. Image classification, that first problem, to this day, no human knows how to write an algorithm that can do that well. So the way we solved it is by, instead of writing that algorithm directly, we created a system where we can feed a bunch of examples of what we would like that algorithm to do into a big computer, into a supercomputer, and it produces the algorithm for us. It writes that function. And so that is a truly profound and powerful new capability that we have. The problem with this, though, is that you need to have a whole bunch of good examples, many, many of them. And that's the data problem. We have to have lots of data for this to work. For many of the AIs that we've created so far, we've been fortunate in that we have actually a lot of data available to us in this thing called the internet. We have a bunch of digital information, particularly when it's about knowledge work. We have lots of text on the internet. We have books, we have articles, we have blogs, we have terabytes and petabytes of that information. So we were able to create these amazing transformer models that we're all using as ChatGPT and Gemini and Claude, et cetera. But for the physical world, the AIs we want to create about the physical world, that data is not readily available. You can't just go download it. Where do you get all of the information you need about physical interactions with objects inside a factory on a factory line that just is not available anywhere? So the only way for us to really get all of the data we need to train these AI systems is by taking the laws of physics, taking the rules of the universe and the world around us, and turning it into software that runs on a computer. That's a simulation. Once you have this, you have the ability to simulate the real world well enough inside a computer. Now this new thing becomes a renewable source of data. So you can kind of think about all the data that's on the internet today as like fossil fuels. It's fossil data. It's the stuff that was just there. We go mine it and then it's done. It's finite and limited. Whereas a simulator can generate new data, and we can generate the data that we need as we need it. And so that's what I've been working on. The trick is, the important part of this is to match the real world well enough so that the data you then use to go train the physical AI is valid, so that the AI actually really understands how the real world works, not just that simulated world. They have to be close enough together, because if the simulated world is too much like a cartoon, then it's going to learn the wrong physics. Fortunately, we actually do have many of the technologies necessary to simulate the physical world well enough. This is something that we've been doing for decades and decades in computer science. We use this to do things like predict the future. We predict weather using simulators that can do fluid dynamics at global scale. We can simulate fluid dynamics over in doing virtual wind tunnels of our cars and airplane wings, and many other things. So we do fundamentally understand that, and then we can go test the robots in the real world. Once we transfer the AIs that we train in the virtual world, we can put them in the physical world and test them against how they were performing inside the virtual world, and make sure that they don't deviate. And we've had great success doing this. We've been doing this for years now. There's many examples of it, that not just NVIDIA, but pretty much every company out there that's doing some form of AI or advanced robotics has been showing success in this realm.
So the real world is unpredictable, right? So let's say an AI is driving an airplane and something goes wrong. So how to approach the situation where human is making a lot of decisions which are spontaneous, based on their experience, based on the data they are able to collect at that point of time. So how to approach that situation? So how do you simulate those edge cases, those black swans?
Actually, that is exactly the reason for why you need simulation. If you're relying on capturing data from the real world as your only source of data to train your AI, then you're unlikely to catch those edge cases and those black swan kind of events. And in many cases, you don't want to catch those events. For example, for autonomous vehicles, self-driving cars, we would like our AIs to really understand what it means when there's a human in the road in front of them. If a child runs out into the street as it's moving very fast down the street, you would like it to have experienced that, but we don't actually want that to ever happen in the real world. So how do you solve that problem? Well, you can do that in simulation. It's very easy for us, once you have a good simulator, to simulate a child jumping in front of a moving car. We can generate millions and millions of variations to that particular scenario, with children of different sizes, moving at different speeds in different scenarios, different weather conditions, different cities. You can model all of those things and generate as much as you like, and it's safe. We can also do this at faster than the real world time. We can generate millions of hours of simulation in 1 hour of actual time if your computer is big enough, if you have a fast enough computer. So this is really the only way to solve that problem. All those black swan kind of edge case events, they just don't happen often enough in the real world, and often we want to avoid them. So if we're going to make our AIs intelligent about them, we have to give them this data from a simulation first.
Yeah, incredible. You mentioned like we're doing this for decades, right? And I'm also teaching like about 10 years now. And the way we teach transforms with all these AIs, and especially with the pace of AI, it's getting faster and faster, a lot of new changes. So we have to adopt. So your career advice also has evolved. So from emphasizing learn to code to new kind of approach, go study the physical world and don't worry about coding. That's because AI will handle it. So reflecting on your
Wow,
journey,
you've done your homework on me.
AI, by the way, helped a lot.
AI helped you,
yeah,
yes.
Deep research. With a paradigm shift of lessons learned to reshaping your understanding of AI potential. So what's your perspective? How we need to adjust the educational system, and how we need to adjust the educators and also students, how they can adjust to be successful?
That's a really good question. And I'm not sure anybody has has the answer yet exactly to what we should be doing. I think this is something we're going to be discovering as we go along what the best way is. But one thing is clear, that it definitely is going to change. It's already changing so fast, and it's already changed. I think the most important thing for our students to develop as a skill, and this has always been true, but it's just even more true now. All the students should learn how to learn. The most important skill you can have is adaptability. If you only learn how to do one thing, one specific skill, and assume that the world is always going to be the same and that skill is always going to be valuable, then you're at risk because the world changes around you. And if you can't learn new things, then you're going to be obsolete. The difference now with AI is that all the technologies that humankind has developed up until this moment have always been about augmenting what humans do. They're tools. The technologies kind of amplify what a human is already doing. For the first time, we have a technology where it actually doesn't have to augment a human. It can kind of do things on its own. It has potentially agency. That's what we're calling them, agentic. And so this is a very different thing than we've experienced before. But if you step back and go, well, have we not experienced it before? Of course we've experienced this. We deal with other agents all the time. I have a large team of people that work in my organization. I deal with them all the time. They go do things on their own accord. I try to align them to what the strategy is for my team, for our company, for the work that we need to do. But they're also very intelligent. They kind of figure out what are some of the problems that I don't know about that and I don't understand that need to be solved for us to be successful. So the way we're going to interact with this technology is not like tools of the past. It's more like how we interact with other humans. Not exactly, they're not humans, but they have some of the traits of what other humans or things that have agency have. And so we're going to have to figure out how to train a generation of humans that are going to enter the workforce on how to be leaders and how to how to lead teams and teams of agents. Most of these agents are not going to be human. Some will, just like we have today. We train managers, we train leaders. Today, basically, they only lead other humans. But in the near future, most of your team members, if not all of them, will be artificial intelligence. They'll be artificial agents. And in many cases, it's going to be a mixture of them. So I think we could look at what we've done in the past to train leaders and try to figure out how to apply that to everyone. It's not only some people that will be managers. Everyone is going to be a manager, at least of teams of AIs.
This comes to a trust issue. So I think when working with people, we trust people, and we trust in their abilities, we trust in their good faith. And when we delegate something, people go and do that. How do you see overcoming this trust issue with agentic agents and robots?
You know, people always phrase it that way, and implicit in that is that we truly do trust other people. But I actually think, from my experience at least, most people don't easily trust other people. This is why we often have problems within organizations, and especially within companies. You always hear about politics. You know, there's politics inside companies. What is that politics? Fundamentally, it's that there's mistrust between the humans inside the organizations. I actually think it's counterintuitive maybe, but I think it's probably easier for people to trust a machine to do what they're asking it to do than to trust a human to do what they're asking it to do. And you already see that kind of playing out in many respects. I don't think that's going to be the problem. But we are going to have other problems. We actually need humans to cooperate and align and work together more. A bad outcome of this would be if people become more isolated and only talk to computers and not to each other. We've been seeing this as a result of people's interactions with social media and being isolated just on their phones. I have young adult children now who are Gen Z. They grew up with phones and being online, and I see it in that generation. You know, they don't socialize in the same way that I did when I was a kid with others. So we need to, I think, be deliberate about having more human to human interactions. We also need to be careful in terms of, as we design these systems, these agents, these AIs, they're going to be very powerful, but we're designing them and we're in control of them. So we should be deliberate to guardrail them and contain them and make sure that any of the important decisions are always checked by a human. They're going to be there to serve us, to do what we ask it to do. We should never allow it to get to a point where that flips, where we just do what it's asking us to do. And I think that might be much easier for people to kind of slip into than we realize. I don't think it's going to be the machines forcing us to do anything. It just, people generally are kind of lazy sometimes, and they're like, yeah, it'll be easier. I'll just ask ChatGPT, what should I do? And it'll tell me what to do. So we should be deliberate and say, no, these systems are here to help us. And the AI agents that we create, they're here to do jobs for us. And if they're not doing a good job for something, you fire them. You can just shut it off and create a new one that does the right job.
Better reprogram it.
Yes.
Recycle. So you are the tomorrow a keynote speaker at the graduation commencement ceremony.
It's going to be a great honor to do that.
And also, you just introduced a scholarship. What was the decision behind?
It didn't really take much thought. You know, everything I've done in my life, I've been fortunate to be able to do because higher education has existed, because the advancement in technologies and our understanding of the physical world, all of that has been going on for centuries and centuries. Growing up in the US, in Los Angeles, we were really fortunate. The California higher educational system is amazing. And there's no question that Silicon Valley and Hollywood, where I worked in visual effects, that would not have been possible if we did not have higher education available to everyone in California, everyone in the United States, and to every person in every strata of society and every socioeconomic position. But I'm an American, but I'm also an Armenian. Once I got the opportunity to come to Armenia after it became independent, it was clear to me that I want Armenia to continue to exist and thrive, and the advantages that I had being born and raised in the U.S., that needs to be available here in Armenia for Armenia to also thrive and exist. And a key part of that is higher education. And it just so happens that the American University of Armenia is actually kind of a spin-off of the UC system in California. This is an amazing thing that exists here in Armenia. A little piece of where I grew up and the advantages I had there is already forming here. And so when I was asked about contributing so that some Armenians can get an education here, it's a kind of a no-brainer. Of course, we should just do it. And we'll continue to do it, and we'll do more.
Thank you for that. And what would be your message tomorrow during the keynote?
Well, do you want me to really give it away earlier? I thought this is supposed to be a surprise for the audience.
The recording will be later, or aired later, so no one will know.
Well, you will know, though. And so will some of the other people that are sitting around here in this room. I'm going to be talking about some of the things that we just discussed earlier. I think the main theme will be about, first, this is a celebration. It's amazing that we have so many students. From what I understand, this is the largest graduating class in the history of AUA happening. So that's going to be wonderful to see. But within Armenia and actually globally in the world, these young people are now entering this world in a very uncertain time. A big part of that is AI. Here in Armenia, we also have our own challenges with national security and the geopolitical tensions. So I'm going to be addressing those anxieties and hopefully point to a path where we can turn some of these things that seem like they're all disadvantages into potential advantages for both the students and for Armenia.
Yeah. Hopefully that will drive them for some time.
Hopefully. I'm sure they will. They're already doing amazing things. I'm so impressed with this generation, the youth that I'm seeing here in Armenia, their energy, their passion, the critical thinking that has formed. I've been coming here now for 2 decades or so, and there's been a monumental shift in an evolution in the culture and the agility of the people between these generations. 20 years ago, you still saw some of the remnants of kind of a Soviet type of thinking in the workforce. But this new generation, they're something special. So I have a great hope for this country.
I fully share your excitement about that. So I would like to thank you for taking this time and for everything you do for Armenia and generally for the world.
Thank you very much for giving me the opportunity to come here and speak with you and speak to your audience. And thank you for all that you do in educating our youth and setting them up so that they can be successful in the world and make Armenia more prosperous and make Armenia great.
I love doing that.
Thank you.
You too.